Hi, this is Miss Wiles and her mad math monkey. Oh, he looks sad. Some of us know why he's so very sad. Anyway, this is the second part of the video series on growth and decay. In this video, we're going to work out two problems together and then two similar problems that hopefully you'll work out independently and be able to come back into the video and check out your answers. Let's check out what we've got here. Now, if you recall, I said that you'd see a lot of growth, exponential growth problems and decay, but more often growth for population. So let's read what we have here. In 2008, the town of Flat Creek had a population of about 280,000 and a growth rate of 85% per year. Write an equation to represent the population of Flat Creek since 2008. Remembering that when we have a growth rate, that this is going to be exponential growth, then we know that our equation, since we're writing an equation to represent that population since 2008, these years really aren't important as far as writing the equation. The format of my equation is y equals a times 1 plus r raised to the t power.
Isaiah Whitted, your ride is here in the front office to pick you up. Isaiah Whitted, your ride is in the front office. Isaiah.
And I didn't get to the pause button in time, so I hope he gets to the office and catches his ride home. But remembering the parts of the equation, when we write an equation, y will stay as part of the equation. T will stay as part of the equation. The A and the R are what I'm going to get from the situation that I'm reading about. So I look at this and I understand what A is. I go back into my recollection and I say, okay, A is supposed to be the first number, or where we start out with, and that's going to be 280,000. We started out with 280,000 people. I wish I had not written this quite so small. I'm going to go in there. All right, because you can see the things that we need to see. So 280,000 and then 1 plus R. Now R is the rate that it's growing. It's growing at a rate of 0.85%. I really should have given myself some more room because I need to change this to a decimal. R has to be a decimal. So I need to change 0.85% to a decimal, and I do that by moving that decimal back 2 places for 0.0085. Once I move that decimal back 2 places, the percent sign is gone. Let me write this a little bit larger. We have y equals 280,000 times 1 plus 0.0085 to the t power. I'm not quite finished yet because there's some math I can do here. I can actually add 1 and 0.0085. So we're going to finish it up with y equals 280,000 times 1.0085 raised to the t power. And that's how you make your equation. Your equation is what allows you to, now if I know how long it has been since 2008, I can tell you what the predicted population would be at that time. It won't be exact, but it'll be a good approximation of the population at a particular time, which leads us to the second problem. The second problem says that in 2008, the town of Flat Creek had a population of about 280,000 and a growth rate of 0.85% per year. According to the equation, what will the population of Flat Creek be in the year 2018? Well, this may be the only question that I actually get on a test, And I need to know that if I'm going to predict something, I either need to make a list or I have to come up with this equation. There are different ways to do it, but if I can come up with this equation, then I can do a substitution. I know that the population in 2018 will be equal to the population in 2008 times the rate of change raised to the t power. Well, now I have to figure out, what is t? What is t? T is the amount of time in years that it's been since 2008. Now let's look at that. From 2008, we're going to 2018. So we've got 2009, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 10 years. It has been 10 years since 2000. And this is when I get to use my calculator, because believe it or not, they don't expect you to do this by hand. So take my calculator and move it out of glare. Actually, I'd like for you to see the buttons that I'm pushing too, in case you need to rewind and see what I'm looking at here. So to do this, I'm just going to substitute or put this in the calculator to calculate 280,000, making sure that I have exactly the right amount of zeros, times 1.0085 parentheses raised to the 10th power. We would expect the population in 2018 to be 304,731 approximately. And that is how we create an equation for exponential growth, and how we use information that we are given to make a prediction about whatever particular values we are computing. Now at this time, I want you to take the next two problems and pause the video and try to work those out, and come back into the video as you need to, or to check your answer. I would suggest checking your answer between A and B. Once you find the equation, check that answer before you go into the next part of the problem. Welcome back. In this situation, we have a school district that had a student population of 4,500 students and a growth rate of about 0.15% per year. The equation will be y equals A, which is 4,500, because that's what they started with, and 1 plus R. R is 0.15%. And change that 0.15% to a decimal, moving that decimal back 2 places. 0.0015 is now R. And that would be raised to the t power. So 4,500 times 1.0015 raised to the t power. Remember that when you're writing the equation, you are writing that equation so that no matter what time is, you can come up with an answer. Go back and do B if you haven't now. In B, we already have the equation of y equals 4,500 times 1.0015, and now we need to find out what t is. We're going from 2008 to 2014. From 2008 to 2014 is 9, 10, 11, 12, 13, 14, or subtract 2014 minus 2008 for 6 years. That's an exponent, remember, because this is exponential growth, and I can find my prediction for our prediction for the population, 1.0015, by just putting this straight into my calculator. Don't do it like that. Change that to a exponent. And we would expect the student population to be about 4540. We don't usually round up when we talk about people because you can't take part of a person and make a whole person. But you may see if it's multiple choice, pick either one. I would accept either answer, and it just kind of depends on preference as to what you're looking for. Now, that is all of part 2 for this video series, and that was on population growth. If you'd like to learn more about exponential decay and see some examples on that, then go to exponential growth and decay part 3. And that's all I have to say about that.